Hello everyone, myself Professor Amol Mishra, Assistant Professor of Department of Electrical Engineering of SND College of Engineering and Research Center, Yaula. Today we are going to discuss on a topic transformer protections. So transformer protection. So first we are seeing that what is a power transformer. Power transformers are the major equipment in the power system network. As you know, the transformers are used to deliver the power to the consumer without changing its power and frequency. The transformer has numerous kinds of protection in order to maintain the transformer healthy at all the conditions of the power system network. Means a transformer, it is a device which is used to transfer the power, electric power from one AC circuit to another AC circuit with change in its voltage and current but without changing its frequency. The list of major transformer protection. First one is OTI means oil temperature indicator. Second one is WTI means the winding temperature indicator. Third one is the Bachel's protection or Bachel's relay protection. Fourth one is the surge protection. Fifth one is the pressure relief valve protection. Sixth one is the differential protection. And seventh one is the restricted earth fault protection. This type of protection are provided for transformer. The transformer protection, the first point is OTI. The OTI is abbreviated as a oil temperature indicator. The OTI or oil temperature indicator is used to measure the temperature of the oil inside the transformer main tank. The OTI means the oil temperature indicator has the temperature indicator connected with thermostat along with the probe. This thermostat is mounted at the top of the transformer main tank. Since hot oil will be at top of the tank, it is mounted anywhere at the topmost part of the tank. The normal OTI indicator or oil temperature indicator will have lobe-like structure inside which the mercury is filled along with the contacts. It is called a mercury switch. This switch is fixed in a circular disc along with a marking scale in it. Whenever the temperature increases, the mercury starts melting and makes the disc to rotate, indicating the temperature. By rotating, the contacts inside the mercury switch lobe get changed from no to NC position, giving signals to the cooling system. This context of OTI is used to control the air force or oil force cooling system in the transformer. Transformer protection. Second point is WTI. WTI is called as a winding temperature indicator. WTI indicator is like an OTI indicator, but here the only change is the thermostat. Means the winding temperature indicator is like an oil temperature indicator, but there is only change that is of thermostat. In winding temperature indicator, thermostat can't be used in the winding to measure the winding temperature. Instead of using the thermostat, a rheostat is being used. This rheostat, having some standard resistance, is connected to the control circuit. Based on the level of temperature near the winding area, the resistance of the device will vary. This value is converted into temperature using a separate current conversion unit and a transducer unit. The output from the winding temperature indicator unit will be utilized for activating the cooling unit. The digital output from the CCU unit will be given to control devices. For both oil temperature indicator and winding temperature indicator, alarm temperature and trip temperature can be adjusted manually based on the user's needs. When the temperature reaches the fixed alarm state, the device will give an alarm indication. Likewise, if the temperature goes beyond the fixed value of trip temperature, the command will be initiated by the protection system to the transformer. Connected breaker to isolate the transformer from the grid. The images are shown of OTI and WTI, means oil temperature indicator and winding temperature indicator. These are the images for OTI and WTI. And next point in transformer protection is the Bachel's relay. The Bachel's relay is an internal protection device of a power transformer. These relays are used to protect the transformer from internal faults. These relays are very fast and sense the internal fault against the transformer. Bachel's relay is fixed in between the transformer main tank and the conservator tank. Bachel's relay has two floats inside it. These floats are used to sense the internal faults in a transformer. And by operation of Bachov relay. For example, there is sudden rise in temperature inside the transformer tank due to some spark or any other burning inside the tank. Due to this, there will be the formation of some unwanted gases inside the tank. These unwanted gases are collected at the top of the Bachov relay, which is installed at the topmost point of the transformer main tank. This results in the activation of Pachol relay, giving alarm or trip signal to the protection system. The DGA sample collection device is also installed with the Pachol relay point. Pachol relay will maloperate if the level of oil inside the relay changes, which disturbs the position of floats under normal conditions. Surge protection. The next point in transformer protection are the surge protection. A surge protection relay is used in the transformer that is equipped with OLTC. Surge relay is installed between the OLTC tank and the OLTC conservator tank. Each phase of the transformer will have a separate OLTC tank. Its working is the same as that of Bachhol's relay, but it has only one blow. It is used to monitor the level of oil in the OLTC's conservator tank and how force the oil enters and leaves the chamber of the OLTC tank. Such relay will not operate during the normal transformer tap changing process. It will operate only when surge develops inside the OLTC tank. Then next point is our pressure relief valve relay. The PRD called a pressure relief device installed in the transformer main tank. The PRD is used to relieve the high pressure inside the transformer tank during a fault condition. The PRD or pressure relief valve has a spring-loaded diaphragm which is designed to release a huge amount of pressure rapidly under abnormal conditions. Based on the amount of oil and the rating of the transformer, the number of PRDs mounted on the transformer tank will differ. The operation of PRD will trip the transformer reactor considering a sudden rise in temperature and pressure as a fault occurrence. Then our next part is in transformer protection is a differential protection. The differential protection is one of the most important protection in the power transformer. Differential protections are employed in order to measure the difference in current between the primary and secondary of the power transformer and take necessary action against the condition. Differential protection schemes of any transformer based on its conversion ratio will have a current transformation ratio. Any difference in these ratio values can be sensed with the help of neutrality. Under normal conditions, changes in the ratio will be minimum and current flowing through the neutral city will be negligible. If fault in any of the phases, the return current will be flowing through the neutral city, measuring fault current. During this condition, the ratio of current will not be the same and hence the relay operates. This protection is meant for transformer, reactor, and busbar protection. For this protection, In the transformers, base city will be used based on electrical scheme. Then our next point is the restricted earth fault protection, in which the relay is used in the transformer for finding the internal earth fault. This is the same as that of differential protection, but it is for sensing the earth fault. Each transformer will have 6 plus 1 CT mounted in the turret and the connected with bushing lead. This relay is connected along with the neutral city. The common phases of individual phase city will be connected to the secondary of NCT in a such a way that the secondary unbalanced phase current of phase cities will oppose the secondary current of NCT. Under normal condition, both these currents will nearly be the same and the relay will not respond. Under abnormal condition, the value will change and the relay operates. Then restricted earth fault protection. In order to nullify the phase shift at bushings of the power transformer, or primary will be delta connected and the secondary will be star connected with solid grounding. The cities are connected star side with delta and vice versa. By connecting the delta side, primary side of cities as star connected, 30-degree electrical phase shift can be nullified. This method was employed in olden days while we are using electromagnetic relays. Nowadays, we are using the numerical relays are equipped and it's not necessary to physically do the right wiring as mentioned above. All the numerical relays have an inbuilt algorithm to sense the differences between the fault and normal conditions. Thank you for the watching the video or subscribe our channel for more electrical related videos. Thank you.